Welcome to today's webinar. Today's webinar, as you all know, is Smarter Reality Capture Workflows with Scan to BIM, presented by Baynes. Today's presenters is myself, Yeslin Pillay. I am a BIM technical specialist in civil infrastructure here at Baynes. Joining me is my colleague Shoaib Yunus, who is a senior BIM technical specialist in civil infrastructure and mining. So, a quick one-slider basically showing you who we are. These are the three main categories we specialize in. First one being consulting, followed by education, and then followed by software and hardware. We also partner with a few cool brands. Autodesk, which you are all well aware of. It is seen as one of the biggest, if not the biggest, in the BIM space. Clearedge, if you're dealing with point clouds and if you want to automate your modeling. Then we have Cool Orange on the data management side of things. Leica from a hardware reality capture 3D scanning point of view. And finally, we have CAD Learning, which is basically an online learning platform with accredited Autodesk courses. From a segmentation point of view, we operate in various segments. First one being building, civil, energy, process plant, and manufacturing. So the agenda for today, I'm going to run you all through the Scan to BIM. What is it? Why Scan to BIM? And some of the benefits and limitations. I will then hand over to my colleague Shoaib, who will go through the BIM workflows and a quick demonstration. Prior to starting, so I want to just make note that this is a webinar. This webinar basically serves as a recap of a previous live event organized by Baynes in Cape Town. These are just some of the images from the event. Also during the live event, the Leica BLK360 scanner was showcased by Shoaib. Let's get into what is Scan to BIM. So before we get into exactly what is Scan to BIM, let's address what is 3D scanning. So 3D scanning is a technology that captures the shape and appearance of the real world environment and objects in a three-dimensional view. This collected data is processed to basically create a digital 3D model that can be used for various purposes, whether that be visualization, virtual reality, or 3D printing. So that's 3D scanning. What is BIM? BIM, Building Information Modeling, is basically a digital system that represents and manages the entire life cycle of a building or infrastructure project. It allows for visualization, simulations, analysis, all before construction even begins. And it also supports the maintenance and facility management throughout the building's life cycle. So what is Scan to BIM? Scan to BIM is a revolutionary process that basically integrates the applications of 3D scanning technology and building information modeling. It combines the capabilities of 3D scanning devices with the power of BIM technologies to create an accurate representation of your existing built environment. This process we've noticed has gained significant popularity in the architectural, engineering, and construction industry due to its ability to enhance the accuracy, your efficiency, and make collaboration much more easier. So what are the results of the Scan to BIM process? The result is basically a digital capture of your existing environment, as I mentioned. This involves using the advanced scanning technologies to collect the data about your physical building, infrastructure, or other objects of interest. Some of the scanning devices that are used to capture this data include 3D scanners, your handheld devices, and even drones that are equipped with scanning capabilities. So once the captured data is processed and verified, it can then be used for digital modeling and design purposes. So this is where BIM software is employed to convert the scanned data into intelligent 3D models that accurately represent the existing environment. These models contain rich information, and they can basically include the geometry, the material properties, and basically the spatial relations of your environment. So the BIM technologies provide a wide range of functionality, as you can see. Some of these include analysis, simulation, clash detection, and even visualization. This integration basically enhances your workflow and makes for better decision making throughout the project lifecycle. Okay, the digital modeling and design process enables architects, engineers, designers basically to work with more precise and reliable information from the offset. So why would you use the scan to BIM approach or workflow? Let's go through some of the challenges you'd face with the traditional workflow. The first one being physical blueprints. So physical blueprints can be bulky, they can be challenging to transport, and it basically makes them less accessible for on-site reference. Blueprints also have a limited visualization. So since it's a two-dimensional representation of your final project, they lack the ability to provide comprehensive and immersive visual understanding of your designs. Blueprints also sometimes lack details. So by this, I mean blueprints may not always provide you with sufficient details for the entire construction process. And this can result in ambiguity, uncertainty, and lead to confusion. This can cause major change order and basically increase the overall project cost. Another challenge faced with the traditional workflow is the capturing of measurements. The capturing of measurements involves manual labor, which can be time-consuming and physically demanding. Measuring distances, angles, and other dimensions of various elements in your project requires a significant effort, as we all know. And this can drastically slow down the overall project process. This manual process introduces, I would say, a level of subjectivity and human error, leading to variation in your measurements from person to person. And we know from this, the lack of accuracy can basically impact the overall precision of the project and lead to a lot of inconsistencies in the final design. As we know now, this is time consuming and physically demanding. We also know that measuring these distances requires significant effort and can basically slow down the overall project progress. Another challenge we face with the traditional workflow is the recording of measurements. So when measurements are recorded by hand, we know there's a risk of it being unclear. And this can happen due to a various number of factors, poor handwriting for one, or unfavorable conditions. So unclear measurements can lead to major confusion, misinterpretation, and subsequently can delay the project progress. Due to the complexity of a lot of projects, the sheer number of measurements that need to be taken is a lot, and a lot of them can be missed during the initial site visits and measurements. Moreover, multiple site visits could disrupt the project schedule, and as we all know, that could lead to even more delays. When multiple site visits are required, these revisions are not only consume additional time and resources, but also introduce the potential for errors, inconsistencies throughout the project. And one of the last challenges that I'm going to go through with the traditional workflow is the drafting. So we all aware in the traditional workflow, measurements taken on site often transferred to hard copy drawings or blueprints for further design and analysis. So overlaying and tracing these measurements on hard copies can be time consuming, and they are very labor intensive, as we all know. It requires careful alignment and precision, as well as the whole manual scaling and adjusting, which could lead to even more inaccuracies. And just as I mentioned, when measurements are not accurately captured on site, this could lead to even more delay and rework. Thus, inaccuracy of information can result in design rework, clashes, or even coordination issues. And these will require a lot of revisions and a lot of redesigns. And with drafting, there also comes a bit of guessing because maybe information wasn't captured accurately. So these are just some of the biggest challenges that we've noticed that are faced with the traditional workflow. So When would you use the scan to BIM workflow? So right off the box, renovations. Scan to BIM can be used to capture accurate as-built information of your existing structure, basically enabling efficient renovations and alterations of your project. We've also noticed that it's very handy for interior designers when they want to capture the spatial orientation of a room. Scan to BIM can also be used for clash detection, coordination, and so forth. The scanning helps you identify clashes and conflicts early on, and these can be directed to the relevant disciplines for it to be fixed before construction even begins. Another place that we noticed scan to BIM used is for historic preservation. It is employed in the preservation or restoration of historic buildings. So these are just a few places that we've noticed the scan to BIM workflow primarily used. So let's go through some of the benefits and the limitations with this workflow. So what are the benefits of the scan to BIM workflow? Firstly, the scan to BIM workflow enables the accurate capture of existing site conditions using these 3D scanning technologies, as I mentioned, whether that be your 3D scanners, handheld devices, or drones. This ensures that the digital representation of your built environment is reliable and precise, basically providing you with a solid foundation to begin any design. By starting off with accurate data, we can make decisions and create designs that fit seamlessly into the existing environment. Another benefit of the scan to BIM workflow is the scanning technology basically reduces the reliance on manual intervention. As I mentioned, the traditional workflow requires a little manual intervention when it comes to site visits and capturing of these measurements. The use of 3D scanners, such as your handheld devices, drones, and so forth, accurately capture the data, eliminating human errors and that level of subjectivity. This reduces the time and effort required for manual measurement tasks and basically increases the overall efficiency of your workflow. Another benefit is that the scan to BIM workflow accurately captures your built environment and it helps you identify potential issues and clashes early on in the design stage. So by visualizing the existing conditions and proposed designs in the initial in a digital environment, stakeholders can detect and resolve conflicts much easily. We can detect a clash, convey that information to the relevant disciplines, and basically this would lead to a smoother project execution and minimize disruptions and delays. Let's go through another cool benefit is that the scanning technology used and the scan to BIM workflow allows for rapid capture of the existing environment in high resolution. So the scanning devices, as I mentioned, capture millions of data points in a short space of time, providing you with a comprehensive and detailed representation of your built environment. This quick data capturing process enables faster project turnaround times and allows for more efficient decision making, and that's very, very important. As I mentioned with the traditional workflow, a lot of site visits are required. But with the scan to BIM workflow, the need for physical site visits is significantly reduced. So your initial scanning process basically captures the necessary data, eliminating the need for frequent site visits if data is missed for additional measurements. This not only saves you time, but basically reduces the overall cost of the project because you've got to take into account travel and so forth. The digital model and information can be accessed remotely as well, so that facilitates remote collaboration. Another major benefit of the scan to BIM workflow is that it offers a cost-saving benefit. By reducing manual intervention, minimizing your reworking, and basically detecting your clashes early on, as I mentioned, this helps avoid costly errors and delays. The accurate data basically allows for better collaboration and overall saves you a total cost at the end. Another benefit, which I touched on a bit, is the reduced rework. So the accurate data that's captured using these scanning devices reduce the likelihood of rework. Design clashes and so forth can be coordinated and conveyed early on and resolved. This can help you drastically avoiding costly and time-consuming revisions during your construction phase. One of the last few benefits that I'm going to go through is that it allows for easier redesigning. I think I've stressed this enough. The scan to BIM workflow basically simplifies the process of redesigning or modifying your existing structure. With an accurate representation of your built environment, design changes can easily be incorporated and visualized to the relevant stakeholders and clients. Now let's go through some of the limitations of 3D scanning. So with anything in the construction industry, it does come with its benefits and a few limitations. And let's go through a few with the scan to BIM workflow. So we know 3D scanning technologies such as your laser scanners and drones are often used outdoors to capture large scale environments. Okay, so if we have adverse or unfavorable site weather conditions, such as heavy rain, extreme heat, snow, fog, this can basically affect the overall accuracy and quality of the scanning. Similarly, with the traditional workflow, you can't really take measurements in unfavorable conditions because it could be raining, could be very windy, and this basically will affect your overall accuracy and lead to more delays in your project. And that applies with the scanning technology. Another limitation of 3D scanning, the areas that you need to scan should be vacant. So to achieve an accurate scanning result, the areas should be ideally vacant or free of any obstructions. Objects or any moving people within the scan area can interfere with the overall accuracy. And this can also be said with the traditional workflow. If you are needing to take measurements of a site, if there are too many obstructions or too many moving parts, this could affect your time and overall accuracy. So it's not only a 3D scanning limitation, but also a limitation with the traditional workflow. Another one is 3D scanning produces large volumes of data, as I mentioned, because it's capturing millions or even billions of individual data points. Storing and managing these large data sets can be challenging, requiring significant storage space and computational resources. And this is a common thing that we are experiencing with modern technology. So you would need to have a proper data management strategy in place prior to visiting your selected site and doing your relevant scans. Another thing is acquiring these 3D scanning equipments can involve a significant investment. So especially for higher quality scanners with advanced capabilities, the costs can stack up. But remember, higher precision and longer scanning ranges often come with a price tag, as we mentioned. So, but it's always important to acquire a scanner or a scanning technology that's fit for your needs. For instance, if you are an interior designer, you're not going to require a 3D scanning drone because you're in a room. So you need to have a scanner that you are using the full capabilities of and fit your needs. And that's something here at Baker Baynes we can actually assist you with. Another little bit of a limitation is after you scan your data or scan the relevant spaces, the individual scans or point clouds need to be aligned or merged. And this process is basically called registration. It can be a bit time consuming, but it depends on the computational resources that you have available to you. Manual registration does require additional effort, but with the right expertise, it can be done very seamlessly and very accurately. Another thing is that the point cloud data that's generated from 3D scanning can sometimes be complex. I like to call it, say it's a bit noisy. It can contain outliers and so forth. So for instance, if you are taking a scan of a room, a tree that might be outside a window would be picked up by the scanner. That's the level of accuracy it goes into. So you would need to take that extra step when it comes to basically your registration process to delete these unwanted or outlying points. And that extra step can introduce a level of complexity and additional time, but it is well worth it, as I mentioned, with the benefits. It's also good to know that while 3D scanning captures the geometry and spatial orientation of your built environment, the resulting point cloud doesn't always translate to a CAD model, or I should say does not translate to a CAD model, and that's very important to make note of. Converting the point cloud into a usable CAD model does require additional modeling and reconstruction processes, and that's where the BIM technologies come into play. So in saying all of this, understanding the disadvantages or the limitations of 3D scanning can help a project team efficiently manage expectations, adjust challenges, and plan for these additional steps and resources required for this workflow. But despite these limitations, 3D scanning technology continues to provide valuable and accurate design data for wide ranges of applications and industries. So I'm now going to hand over to my colleague Shoaib, who is going to go through a demonstration and the overall workflow of Scan to BIM.
Thank you, Yeslan. Let me just share my screen. Okay, perfect. Hi, everyone. Thank you for attending this webinar. Thank you, Yeslan, for that good foundation on what we're going to be covering. And I'm going to be taking you through the refined Scan to BIM workflow. So now, as Yeslan has mentioned, the point cloud does not equal a CAD model. You will get the representation of your reality, hence the word reality capture. But you would still need to trace and model over your reference, which is a big plus in whichever industry you're in, meaning that you will have your site in your laptop, which is quite nice. But what if we could further automate it and help you more on the modeling side? So you're going to see some really, really cool stuff right now. And that's why I called it the refined Scan to BIM, because there is much more automation that you're going to be seeing, especially for generating models. Right, so the refined Scan to BIM workflow, what does it incorporate? So we did a live event in Cape Town, I think a week or two back, and this is just a recap of more or less what we did. So of course, you're going to need your hardware. In this case, we used the Leica solutions. You would scan your model. You would then need to, of course, process it onto your laptop or register it. And the refined portion of this workflow is actually where clearedge 3D comes in. You'll see it in a bit. From there, of course, you'll take it to your authoring tools. In this case, we use Autodesk. I mean, it is a global leader in the BIM technology space. Of course, it then goes to construction. And then you would repeat that to capture the as-built. So scan, process, extract, which is a very cool thing, model and visualize, construct, and as-built. Right. So it's a bit of a round trip, but I thought it will be quite nice to demonstrate, because sometimes you might start at a certain point. You might not be at the start, you might be at the middle of this workflow. But just to give you a quick rundown. So of course, as we'll capture, we're going to be using a laser scanner, 3D laser scanner. In this case, it's a fixed scanner on a tripod. All right, so that will capture your reality. Pretty cool with the images. Then we would need to register it and take it into the BIM intelligent applications. From there, once we have a registered point cloud, we then can take it into point cloud geometry extraction technologies. In this case, it's going to be clearedge 3D. You're going to see the magic that's going to happen right there. But what it does is it will extract the geometry for you as much as possible. So you can then take it into AutoCAD, you can take it into Revit, model, plant 3D if you're on the plant side, and you get intelligent objects that you can work off. And from there, you could be a bit fancy and you could create some really cool videos and realistic visualizations. So that is more or less what I'm going to be showing you right now. So just to touch on the technologies, because I don't want to go into this where you don't know what these technologies do. So of course, we've got the scanner as well as the accompanied software solution. So in this case, it's the Leica suite. We used the Leica BLK360 laser imaging scanner. So this scanned our environment. This was in conjunction with the Cyclone Field app, which you can use on your phone or on your tablet. In this case, I used a tablet. It's quite nice. You can visualize things much more better on a bigger screen. And what it allows you to do is when you are linking scans, you could actually do it on the go while you have your project going on site. So this also makes it much more easier in the registration process. So once you've got the scans linked onto your iPad or tablet, you can then transfer it to your desktop just for further fine tuning and getting it more accurate. You can also interrogate the data a bit better. That's where Register 360 comes in. And then of course we can export it to Autodesk, which is an RCP format or Recap Pro format. Now, clearedge 3D, some of you might not be aware of this technology, but is absolutely amazing. It can be applied in a variety of environments, whether you're looking at extracting pipes, structural elements, ducts, walls, conduits. Sure, it's quite a long list of things that it does. But what it does, it will look at your point cloud. You can then select what you would like it to extract. It could be a combination or just a certain portion of it. So if you're only interested in, let's say, the walls, you can only take on the walls. If you would like to get the walls with the structural elements, so like steel profiles, as well as the piping that is available in your scan, you could tick all of them on and it will extract it for you. I'll give you a quick overview of what it looks like. I'll just scan through this video very, very quickly. But what it does is it can be used in a variety of different environments. So here we've got, this was extracted from a scan, believe it or not, and through the algorithm, it can now actually connect those pipes for you. Same with the structures. So if you have a point cloud where the steel members are normally center to center, pretty uniform, it would extract and create these steel profiles for you automatically based on the pattern recognition that is built into the software. This is zero human intervention, right? So what it will do is, depending on the density and the quality of your point cloud, it will now extract the elements for you. You can see this is the point cloud, and we can then reference it back to see the accuracy. Of course, you can also change the diameter of the pipes, the thickness of the walls, and so on. All of that can be done. But again, it all comes down to the quality of your scan data. So you can see here, these are some piping here. You probably missed, maybe the quality wasn't great, but based on the algorithms that are built in, it will give you a best fit connector, for example. Here you can see we brought in a variety of different scans. You can then, of course, then go and toggle your bases and pipe extraction rules. You can see those gaps are due to maybe lighting or the density of the point cloud not being that great. So the tracing of the algorithm wasn't like to the T. But again, you've got the point cloud recognition technology where you could create those connectors for you on the go. And then, of course, you can export it to AutoCAD, Revit, or Plant 3D, or whatever you may be using. The structure one is pretty cool. So you could actually designate or highlight an area of a profile. So there's the steel profile. And what we'll do is you gave it a base basically to extract, and it has extracted the corresponding geometry. So here you can see we can do a patterned extract, and it will extract those members for you in CAD. That is CAD, what you're seeing on the screen. No one drew that. Based on the properties of the point cloud, it was extracted, and you can see it did a pretty good job of that. And then, of course, you can take it into Revit, and I mean, the rest is quite self-explanatory. I mean, there's more you could go into. You could, if you want more info, you could always reach out to us. But just to give you an idea of the complexity and the reach of this tool, can be applied in a variety of different environments. So today I'm going to show you from the Autodesk tools. These are the ones that you're going to be seeing. So Recap Pro, Revit, and of course Navisworks. They are all a part of the AEC collection, so Architecture, Engineering, and Construction collection. It's a bunch of tools that have been bundled together by Autodesk for users in this segment, because we're always collaborating and sharing with each other. And if you have these tools, it makes the collaboration much more seamless. So let's get into the fun part now, the demonstration of the workflow. And we have tested this for ourselves, right? They say the proof is in the pudding. So I thought I will give it a test drive, and it was quite nice. So previously, before we moved into our new offices here in Sandton, Sunning Hill, we had to plan our layout. And you can see on the right-hand side, that was the space that we moved in. And what we wanted to do is apply this workflow to see if it will help us, and it definitely did. So we needed to put in our offices, the drywall, where we're going to position stuff, where we're going to put the furniture, and so on. And I used this workflow. Let's see what it does. So the first part, of course, is the scanning. So we use the BLK 360. We are on this portion of the workflow. And this was the scan, right? This one is actually of the, let me see which one this is quickly, because we also did a live scan at the event. This looks like the event room scan. So for those, I see there are some people that did attend the event. So what we did was we generated a quick scan to show you the room that you were sitting in. And you can see there is quite a bit of noise here. So we could just crop it quite easily. That's not an issue. It's a quick thing to do, right? And you'll see in a bit when I zoom into this actual scan, I can go and preview the room that we were in. So this was just before everyone arrived, right? So we did a nice quick scan. This was the room that we were presenting in. You could see, you could look up, down, left, right. We were, of course, hiding out of sight, but it was pretty quick and easy. And you could see the clarity of the data is quite amazing. We just did about 3 scans. That's what you would see on the plan view on the top right corner. And this is what we captured. So the point cloud was done pretty seamlessly, pretty easy, and it was linked quite accurately. So this was the scan of the event area that we were presenting in. Of course, you can then go and take some quick measurements. You could add a lot of notes if you'd like, and so on. But that's just to give you an idea of, we did it on the day. Now, when it came to our office, this is more or less what it looks like, even of the actual venue that we did scan, right? So this was just to give you a preview of how it would look on a tablet or iPad. You can see it's our Baynes offices, and we could go and zoom in, measure, and so on. And you would continue like this as you're going along the area that you wanted to scan. When it came to the linking, you can do it as you go on site. So this was just an example where you would have a pre-align option on your tablet or on your phone, and it will link it for you. Now, if you're not happy with the creation of that link or the optimization, I mean, you could go and move this manually. You could rotate it to make it even more accurate, but generally the algorithm is pretty bang on. So you could actually accept that link, create it, and optimize it so that it can then be linked accordingly. So you would take the scanner, you would scan your entire area that you would like. As you can see on the screen, there's quite a few setups of our office that I did, and all of them are linked. Even if you look at the top right corner, we intentionally rotated a portion so that you could actually fix it on the desktop. So if you make a mistake on site, it's not the end of the world or a train smash. You can actually interrogate it onto your desktop, and you could fix it accordingly. But here you could see we had a combined point cloud of our office. You would then need to transfer it. So this is on the desktop now. I can simply connect to the field app on my tablet. It will create an IP address using the sync server option. You can then test the connection, and then it will tell you it is successful. And then the rest is quite easy. You simply click add to project. It will pick up every single project on your iPad, right? So if you have quite a busy iPad, you'll see in a bit, I had quite a few projects on the go. There you go. You can see all those different tabs are different projects. There we are, a few tests, scans, and so on. But there were quite a lot of jobs on here. And the one that we were interested in is the office scan. So I can go and untick the rest of them. Oops, I'll put that back on. And Yeah, you tick which ones you want basically, and you can then start importing. You can simply hit import. Now, if you didn't do the linking on site, you could simply leave the auto cloud on and tick the smart align. So it will start the recognition. It will take a bit longer because now it's going to start going through the point cloud scans that you have captured to try and match it for you. But if you have done the linking before, you could simply click pre-registered and then hit import. Right. Now, once we have got that in, we need to process it. This is where we go into the desktop phase of the actual project. You can see we linked everything. We've got a pretty good accuracy. 1 mil is a very good, right? So you can go and then have a variety of different options that you could go and interrogate. So for example, if you're not happy with that link, you could delete it. You can go and match it accordingly. You could slice it. You could do manual registration. You can see there's 2 scans there, and we could go and like manually move it based on our human perception to get it as close as possible, and then it will generate a link. So there's a lot of options. If something doesn't line up, or maybe the link was done incorrectly, you could delete it and create your links, as well as set on the option to show suggested links. So the AI would look at what links could be viable or feasible. You could work with that. So once we are happy with our scan, we've checked the accuracy, all good to go, then we could then go and edit the report. Here you could see we could generate different fields. You can put in your company name, your logo, whatever it may be, but we are more interested here on the actual publishing. So publishing now gives you a variety of different options, of course, from the Leica as well as other industry norms, like PTS is quite common, E57 as well. But the downside is those formats, sometimes it doesn't go with the photo that's attached. So I'm going to export it to an RCP so that I can now bring it into the Autodesk world. And then I could use, for example, AutoCAD, Civil 3D, Plant 3D, Inventor, whatever it may be, and I could do my modeling there. Now, before I go to the modeling, I would now want it to do most of the work for me, right? I wanted to extract, for example, the walls in our case for me, and I could actually edit that quite nicely. So that brings us to the extract portion of the workflow. This is where clearedge comes and really blows our mind. So that process scan that I have done in Leica registered 360 and exported to recap, I'm going to go and select it. So there it is. It will bring in that point cloud quite quickly, and then I can go and ask it to extract whatever I want. I have just left the tick for each option on. So for building, piping, and ground, even though we don't need piping and we don't need ground in this office space, but you could see I just left it tick so you could see how the algorithm will start working. So once I hit start, it will start going through the variety of different options. So you can see first it's going through the scan data for the batch extract. If you're doing a very large project, I would suggest leave this overnight, come back in the morning, and it's done. This one took about 20 minutes, or probably less, for our office because it wasn't really a huge space. Okay, but what it will do now is it will start going through these options that you would have ticked. So you can see it's looking for pipes. It will go through there. Now it will start extracting the walls. This is what I was interested in, the wall component of it. And it will start and it will go through the emotions of analyzing the data. And once it is done, it will tell you, of course, it is complete. Now check this out. If I hit OK, you can see all the noise around. Of course, I can go and crop it here. Right, so the trees and stuff, it picked it up. But look here, it actually extracted the wall profile from the point cloud. Again, I did not model anything, it did it for me. You'll see there's a bit of gaps here and there. That comes again with the point cloud, the density at that point, whether the light refraction was a bit too much, it wasn't as dense to extract, but you get the idea. If I switch it off, this is what it had. Now, if I wanted, I could simply sweep one wall there because that is one continuous wall, or I could go and edit that in Revit. It's totally up to me. But I'll show you the editing tools that are in clearedge. it's quite easy to maneuver, to be honest. It's very easy. I know a lot of people will prefer doing this in Revit, probably myself included, but just to show you that if you wanted to tidy it up a little bit, you could do it here first and then import it into Revit or export it into Revit. So of course you can go and select or set your levels. These could be on your predefined elevations, or you could just use the point cloud elevations. This can be mapped later into Revit. So those blue planes were what the software extracted automatically. I think I'm just going to go and crop it, so I just focus on this portion here, and now it's much more cleaner. So these are the levels that it extracted. Of course, I can go and delete the levels that I don't want. I probably just want the ceiling level and the top of floor level at the bottom. I can go and customize it based on the axes and so on. So once I have tidied this up, I can go and edit the actual walls themselves. So I can switch off the point cloud. I've just left it on so you could have a reference for it. Now we can kind of tidy it up. So for example, I could sweep that walls that have those gaps in them, and I could join them quite easily. At this portion here, we had a wall that was protruding out. That's why this is not aligned. But you can see how easy it is to just sweep, and I could actually delete those portions. I could even move it left to right. I could even make it thicker. So if you don't want the actual geometry is, maybe it's a few mils off, you can actually adjust it in here. Now, what happens to the portions that it actually has missed? So let's say this red wall, it didn't know what to do, or it didn't extract it correctly. I could go and define that area manually rather, and it will automatically extract it. So it will say, okay, this is actually a wall, and it is located at that portion because it's kicked in. And after a few seconds, you can see it did extract it as a proper wall. And then, of course, I can go and adjust the alignment if it is slightly off, and so on. So you get the idea. It's quite easy to maneuver around here. So once I'm happy with this, I can then go and export it to Revit. You can see there's an export to Revit option on the top. We can also export it to AutoCAD or Plant 3D or whatever, but we want to work much more intelligently, especially in the building environment. You can see there are a variety of different formats that we could use. And once it's done, we can now open up in Revit. So here's the processing of the export. It will be done. I can now switch over to Revit. And if I go to my Edgewise Import tab that I've installed, you can open the model, select your extracted walls, and hit open. Now, when you do that, it will give you an option to map it to the Revit level, like how you would want it to be in Revit, or you could take the Edgewise level. I mean, whatever is suitable to your project. I'll just hit, for example, here, it'll just tell you there's no orientation yet. We can then import it, and this is the result. If I switch over to the 3D view, let's try that again. Okay, there we go. And this is the result. You can see how neatly it came in. So after you have touched it up a bit, I mean, even in here, there's not really much to do. I could delete, of course, those outside doors. It recognizes them as walls, so I can go and delete that. I don't need that. But now editing is much more easier. It comes in as an intelligent family, as you saw on the left, and I can go and really beef it up to the detail. So just imagine how much of time this is actually saving you when it comes to modeling, right? That's why we say it is refined. It's saving you a lot of time tracing all of this. So in this project, it saved about 90% because it's a fairly simple office space. But on average, on very huge commercial industrial projects, the average or the norm is between 70 to 80%, which is still massive. So once we've extracted that geometry, the architects got busy and they started modeling. And this was the result of the office. The architect modeled it quite beautifully. And this was the result. We put in all our furniture, we put in the textures, the colors, and so on. And this was the result. So then I took it a bit further because we wanted to visualize it in context. And this is where I use actually Recap and Navisworks Manage for this. So just a pro tip here. if you want to go on this route for visualization, the point cloud and the model need to be at the exact XYZ. If it is not, you're going to have a problem. You could move the model to the position of the point cloud. Worst case, I do not recommend that, but you can. And of course, I mean, Navisworks with the trees on the left-hand side, the selection tree, you could really mold this or visualize the things that are important. And as you can see, my point cloud set exactly where the model is. So if you have this problem, line it up here and then proceed to the steps you're going to see in a bit. Okay. Right, so this is Navisworks, the Revit model in Navisworks. I can save it as an NWD and we're good to go. Right. Actually, let me show you this very quickly. So once we've got this saved as an NWD file, let me just skip a bit. We come into Recap. So Recap Pro, this is the point cloud, and you'll see it has an option to attach a Navisworks file. So it must be an NWD file. It has to be an NWD file. And you can see it attaches it quite successfully. Now, a lot of questions I would normally get, this is a common one. Where is it? So let's zoom in. Right, so maybe I'm going to fly a bit like Superman. Here we go, Iron Man. And there's no model here. Now, don't freak out if it says it's attached successfully. All you need to do is simply click Real View. Real View will give you the context or in-environment photo view, and this is the results. So you can see I'm in one of our rooms here. It even brought in the texture of the carpet that's currently in the office, which is pretty cool. So you can get a real world feel of how your model would look. You can see even the facebrick came in. Let's toggle to another view or another position where the scanner was placed. So I had it over here. You can see this is the overlay of the model with the scan data. And I can simply toggle around. I mean, this is absolutely amazing. You could actually visualize this to the T way before construction, or maybe you want to pitch a project. This is the way to go. And you can see how realistic this is. I mean, we even have our printer in here, right? So we really planned it quite nicely, and the scan data made it quite amazing to actually achieve this. So once we have it in there, what options do you have to visualize it? I'll show you the easiest one. You could simply take a snapshot. So instead of screen grabbing or snipping, use the tools that are in Recap Pro, because you can adjust the quality of the image. Depending on the screen resolution, snipping is not that great all the time that you're using. This, you could actually customize it, and I'll just show you the product of the snip. You can see it's pretty clear, right? So you can incorporate this into your presentations, your reports, and so on. And we could also do like a variety of different videos using the view states. Now I'll show you the one or the video that I've created for the office very quickly. So this is all done in Recap Pro. I didn't use any other additional software. It's built in. It will link in these transitions and so on based on your view states that you have captured. And I mean, the more creative you are, the better it will be. This is okay video in my opinion that I've done. It was very quick, but it gives you an idea of what it was before and what is now available in that space, which is pretty cool. So if you wanted to create a quick video just to convey your design intent, this is very easy to do. It's very easy, and of course it's very cool. Okay. So yeah, this is of our office, and I actually did one of the room in that we had our event in last week. So I'll show that one to you. I think it's much more relevant. So this is the video that I created of the room that we were in. You'll see in a bit. I will start moving. Right, so this is when you enter. This is the coffee area or the kitchen portion of things. And you can see it's overlaid with the point cloud. So this will give you an idea of the coffee area. We can take a look. You can see it even captured the steel profiles. Okay, and you can see the point cloud also aligns to it pretty good. So we can like hop around and see what's around in the venue. So for those that weren't there, unfortunately you didn't get to see this, but at least you get to see the product of it. Right. So you can see it's a pretty trendy venue. A lot of build professionals normally come here. This is where myself and Jesslyn were presenting from. Okay. Yeah, so we had a projector that was set up here, nice big one, not that small screen. And this is where, of course, the audience was sitting. Now I can also switch this, of course, to the point cloud, or if you're interested in intensity, we could also switch that one. So this was off the actual venue. You can go check it out, the building center in Cape Town. And that was a quick short video that I had exported. Right, now if you want to be even more cooler, I'm going to give you something. So I hope your phones are close by. This is, of course, of our office model, where we created a panoramic VR with the use of the render gallery in Navisworks, right? So you can go and use the realism. So you could use an avatar and you could look around, but you could also publish this to the Autodesk rendering gallery, and then you could generate a QR. So what it will do is you will have to set this up based on your viewpoint. Once the viewpoint is set up, then you would need to go and export it to that render gallery, check it out first, and then you can export a QR. So it will email you to tell you, hey, your stuff has been done, and I can simply click sign in, and I can switch to my render gallery. So this is what it is. And I could go simply click on view project, and you will see in a bit when I scroll, it looks pretty cool. So if you have like a Samsung headset or any type of headset where you could slide your phone in, you could simply look left, right, up, down. I mean, you could do whatever you want. You could walk through the space. If you don't have a headset with you today, it's okay. You can simply scan this QR code. So I'm going to leave it on here for just a few seconds so you could check it out on your phone itself. So when you scan this QR code on your phone right now, it will ask you to open up a link. Again, it works in your browser, so you don't need any special software. It will open in Google or Firefox or whatever browser you're probably using on your phone. And you could then move your phone to the left, to the right, up and down. You'll be able to see our office in a BIM model. So I'm going to leave this on for like about 10 more seconds. I'm sure you probably have captured this right now. Let me know in the chat what you think. I think it's pretty cool and it's quite simple to do. Okay, 5 more seconds. 5, 4, 3, 2, 1. All right, so hopefully you got it. If you have a Samsung or phone of that like, it will normally, if you point your camera towards it, it will automatically pick up the link. I think if you have a Huawei or phone like that, you would need to take a photo of this first and then go to options and click scan QR code. But both work. We've tried it at the event. It worked amazingly. Everyone's did. We all had different phones, so whether you are iPhone, Samsung, Huawei, it all worked. But just to give you a preview, if you didn't manage to get it done right now, this is what it looks like. So I opened it on my Samsung. There we go. You can see the web page will pop up. I can just hit open. Again, I'll just use Google Chrome in this case. And this is what you should have seen. It will be a split screen because it was generated for a headset. But if you don't have a headset, you could click that bottom button and it will create a full view for you. So you can see, you can have a quick look around of the office, which I'm currently sitting in doing this webinar, right? It's more towards the left of the screen where you can see how cool this is. So you could actually share your design intent quite nicely. So once you've visualized and portrayed your design intent, of course, we needed to construct our office, which brought us to this portion of the workflow. So this was it before, and this was it after. So we really changed. You would never say this would look like this, right? So we really planned this to the T using BIM technologies, scan to BIM, geometry extraction technologies, all those type of things. And we then needed to complete this workflow by capturing what we had built, hence as-built, and you simply repeat these steps that I've showed you. So you would need to scan it again, readjust it quite quickly, extract it if you'd like, or you could modify the original design model and you're done. So that's why I've got all three brands at the last, or the as-built phase. So I'll just show you quickly. This was the as-built scan, done and dusted. Again, it filtered through the glass and captured the trees outside. You can see that's me there sitting, my buddy the Neil, and we captured more or less what we did. You can see it was still quite messy. We just moved in, so we're still getting things set up quite neatly. But you can see the point cloud was pretty good. I mean, you could still read the text on our red wall there, which is what we do, right? Once we got the as-built scan, we overlaid it onto the design model, which we had done by our architect. And you can see there was a slight discrepancy in certain portions. So example, the lining as well as the face brick wall was a bit thicker than we anticipated. So you could actually go in now, either adjust this design model and save it as an as-built model, or you could run the extraction tool again. It's totally up to you. I ran the extraction tool again just to test it one more time, just to show you how cool this was. And you'll see that it picked up way more walls, right? All the drywall that we put in, it picked up all of them. So that's why we have a lot more walls, a lot more offices. And this is the results. And you repeat what I've just shown you previously. And that was it. We had the final as-built model that you would normally hand over to your client or the custodian of that building or data. And that brought you to the end of our workflow. So to conclude and to close today's webinar, again, I wish you all were there for the live event because it was really cool. You could have played with the scanner, but check it out in person. But you could always pop by or reach out to us if you want to grab a coffee or something. But just a quick summary. We used the laser scanner as well as the accompanying software, in this case Leica, to capture the environment. We then linked it on site and then transferred it to the process phase, which is the desktop, for really improving the accuracy. We've got a mill accuracy on this office. From there, we exported it to RCP, which is a recap file format, which is recognized in Autodesk applications. We took that to the extract process, which is mind-blowing, where it extracted the walls for us in this case. But you see that the tool can be applied in the plant environment as well as the structural environment as well. In this case, we applied it for the walls. It extracted the walls thanks to clearedge 3D, and then we took it to the model and visualize phase, and we use the Autodesk tools of Revit, Recap, and Navisworks Manage to model and visualize and create really cool videos from our data. We then were happy with it. We sent it to construction. The guys came and put in the drywall, set up everything, and then we repeated those steps. So then we scanned the as-built, we compared it to our architectural model. We then extracted it, and we got our final model of our office. Right, so how can we help you on this, especially if you are really interested in it or you use it in quite a bit of your processes on site or in your environment? Yes, gave you a really good foundation on where the benefits are, where supposed limitations can be. I think based on expert advice, most of those limitations can be eliminated. I can guarantee that, right? So of course, we would like to solve your problems using digital transformation, helping you to design and make a better world. We really do that. You saw it was actually on our red wall if you paid attention to the scan. And these are the two main steps that we could actually propose to you. There are many more. Again, we could grab a coffee or you could reach out to us. But we could educate you to how to use these tools, technologies. You might have them already, you don't know how to use them, or you might need to refine your skills on that portion. You can really reach out to us. We currently have 3 CPD accredited courses. So I think it's Civil 3D, InfraWorks, and AutoCAD. So that's pretty cool. We've also got online learning on the go with some of the courses online, also CPD accredited. But if you are on the intermediate/advanced scale of things, you could reach out to us to create a customized course. So you don't have to do the fundamentals. You might have specific challenges that you would like to be solved in your environment. Reach out to us and then we can create a custom course tailored to you. If you are a business owner, I mean, we could assist and consult with you based on your teams, your technologies, your processes, how you would bring them together to make you much more efficient, much more optimized, much more innovative in your environments, and as well as your different departments. So we could look at your workflow integrations, we could look at recommendations that could work much more better based on the technology that you have. Maybe if certain technologies are redundant or they are better alternatives that are more cost effective, we could also help you with that. And my favorite one is, of course, the pilot projects, where I would get consultants or organizations calling me, where they have landed some really good work and they would like to apply it in a BIM environment. So you have a variety of options. We are here to help you with that. So if you want, you could always hit us up for a chat.
We solve our customer problems through digital transformation, helping them to design and make a better world. Get in touch and let us help you solve your problems. Connect with us on our website, LinkedIn, Facebook, Instagram, or email us on info@bakerbaynes.com. Don't forget to share, comment, like and subscribe to our YouTube channel. Access a variety of tools including ebooks, training videos, content, templates, and guides that will aid in your digital transformation success. Some of these resources are free. Visit tools.bakerbaynes.com today to find out more.